Hello everyone. I made this recording to assist you in filling out this Excel spreadsheet of our data from our enzyme kinetics experiments that we did in lab, and how you can use this to produce a file that we can load into Mathematica. So I'm using some data that Jessica and Catherine collected on Jessica's mutant, and so there are some data that you are going to have to enter, but others that you should write formulas, and I'm going to show you how to write the formulas. So Jessica calculated her enzyme stock concentration using the BCA assay, and it's 0.571 mg per mil. The molecular weight of her mutant is recorded here as 39,740. So the next thing we need to do is calculate the enzyme stock concentration in molarity. So milligrams per milliliter is the same thing as grams per liter. So if we take that grams per liter divided by grams per mole, we should end up with moles per liter. So that's the concentration of the solution in molarity. We can convert this to millimolar by multiplying, times 10 to the 6th. And we can get the concentration in micromolar. Now, some of you diluted your enzyme. Jessica said that she did not, so we'll just say 1 to 1. So we'll just do equals and then just copy this. So there's no dilution factor. But if you diluted your enzyme by 1 to 3 or 1 to 4 or 1 to 5 or 1 to 10, you would put that information there. And then you would account for the dilution factor in your working solution concentration. So most of us used 10 microliters in the assay. If you used a different volume, you should record that there. And the final assay volume was 3 milliliters or 3,000 microliters. So that means we need to calculate the concentration of the enzyme in the assay in nanomolar. So we need to do a V1 M1 equals V2 M2 calculation. So if we use 10 milliliters of an enzyme solution that's 14.4 micromolar, and then we divide by the total volume, that's the value that we would get in micromolar, but we want to multiply by 1,000 to get this value in nanomolar. And we're going to use that later when we calculate the K observed. So it needs to be in nanomolar. Okay, what about the substrate? I took 315 milligrams of OAA and I dissolved it in 53 milliliters of water. And I did this because adjusting mass can be difficult. It's easier to adjust volume. And that's the molecular weight of the OAA. So if we calculate the stock concentration solution, first we have to take milligrams per milliliter, which is the same as grams per liter. So if we do that and divide by the molar mass, we will get the stock concentration solution in molarity. If we want to convert this to millimolar, we should take this and multiply by 1,000, and that's the concentration in millimolar. The next thing that I did is I made another stock solution where I took that solution and diluted it 1 to 10. So that solution will be 4.5 millimolar. So these are the volumes that we pipetted, and first we use the 4.5 millimolar solution. So I'm just going to copy that there, but I want to copy this for the rest, so I'm going to use an absolute reference. So $B, $25, now I can just copy this for the other solutions, and I'm going to do the same thing over here because we use the 45 millimolar solution. And again, if I turn that into an absolute reference, I can just copy this. Okay, so those are the volumes in the solutions that we used, and now we want to know the OAA concentration in the assay. So again, we do a V1 M1 equals V2 M2 calculation. So if we have 3.2 microliters of a 4.5 millimolar solution, and we had a 3,000 microliter assay, that would actually give us the concentration of the solution in millimolar, but I want it in micromolar. So we're going to divide by 1,000. sorry, we're going to multiply by 1,000. Okay, so we're going to multiply by 1,000 to get it in micromolar. Okay, so I want to copy this. So since I always go back to this 3,000, I'm going to turn that into an absolute reference, and now I can copy the rest of these, and that gives me my OAA concentration in the solution in micromolar. Okay, so these are the velocities for both trials that Jessica and Catherine got when they measured the velocity of the reaction. We want to calculate an average, so we'll just use a built-in Excel function where we look at the average of these two. And I can copy this now. I want to convert absorbance units per second into micromolar per second. I'm going to first multiply by -1. And I'm going to do that because we saw the absorbance go down as the NADH was consumed. And we are going to define the velocity as the disappearance of NADH, so we can use a positive number. So the next thing I want to do is I have the extinction coefficient for NADH in micromolar. So if I use Beer's law, I'll take the absorbance divided by the extinction coefficient, and I don't have to worry about the path length because that's just equal to 1. And then I get the velocity in micromolar per second instead of absorbance units per second. And I'm going to want to copy that too. So I'm going to change the L7 into an absolute reference, so I keep going back to my extinction coefficient. Okay, so that's for the velocity for the first trial. Let's do the same thing for the second trial. So that's going to be that absorbance divided by the extinction coefficient, and I'm going to copy, but again, I'm going to need to change this to an absolute reference. Okay, so the next thing I want to do is I want to calculate an average. So again, use a built-in Excel function, and that's my average. Let's copy here. Let's convert these to nanomolar per second because, again, we want to calculate K observed and we want the concentration units to be the same. So for trial 1, if I take micromolar per second and multiply it by 1,000, I get nanomolar per second, and I can copy and paste there. And for velocity 2, it is right here, multiplied by 1,000 to get nanomolar per second. And to get the average, I'll just use the built-in function again, and average velocity trial 1 and trial 2. Okay, so the next thing I want to do is I want to calculate K observed, and K observed is the velocity divided by the total enzyme concentration. So we'll get units of reciprocal seconds because, again, the concentration units of nanomolar are the same. So for the first trial, if I take the velocity and I divide it by, and I have to go way back here and look at my enzyme concentration in nanomolar in the assay. So that will give me my K observed. So again, I want to copy this. So let's convert this B16 into an absolute reference, and I can copy that. And for the second trial, same thing. I'm going to take the velocity for trial 2 and divide it by the total enzyme concentration, and again turn this into an absolute reference and copy it, and then I can finally average it. So average these two values and then copy. Okay, so now what I want to do is I want to enter my data set into Mathematica. So I'm going to want to calculate, I'm going to want to enter the OAA concentration in micromolar and the K observed that I just calculated. So this top block right here is going to be for the averages. So the OAA concentration is way back here. So here's the OAA concentration in the assay. So I'm going to copy this. But when I paste it, I want to paste just the numbers. I don't want to paste anything with formulas into Mathematica. So where it says paste options, when it says 1, 2, 3, that just pastes the numbers. So if you kind of scroll through here, and it keeps a lot of significant figures, but it just pastes the numbers. And the same for the K observed. I'm going to want to take the averages of the K observed again and copy those. And then paste, but I'm just going to paste the numbers and not the formulas. So then there's a little bit of a break right here. And the next thing we want to do is I can just copy these again because I want to do trial 1 and trial 2. So I'm going to copy these values and then just paste the numbers. And then I'm going to do this again and just paste the numbers. So if I'm going to do trial 1, K observed is here, again, copy, but when I go over here, I'm just going to paste the numbers. That's trial 1, and this is trial 2. Copy and just paste the numbers. And now I have something I can put into Mathematica. So what I'm going to do now is I'm going to start a new spreadsheet. I'm just going to have a blank workbook, and I'm going to go back to this workbook, and I'm going to copy just the numbers, not the heading. So I'm going to copy this and go back to my new blank worksheet. So again, I have that little space right here, and I just have my numbers. So again, averages on the top, and then trial 1 and trial 2 are on the bottom. And what I'm going to do now is I'm going to save as, so save this on my G drive so we can have it in class if we need it. Let's put this in my Mathematica folder. And so I did this once before, so I'll just give this a different name. But I'm going to save this as a CSV file, not as an Excel file. So it needs to be imported into Mathematica as a CSV file. And then I'm going to hit save. This is the second time I did the recording, so I guess I will go over and I'm going to replace that. So now I have a set of numbers that I can load into Mathematica. So in the next video, we'll show you how to do that.